Today we're starting Unit 4 and looking at our first lesson, which has an unusual name, lots of flags. And you can see our learning goals here. But as we start Unit 4, which is about percentages, we're going to be looking at a lot of things that you're probably familiar with and just kind of tying some math together with it. So our goals today, we're going to remember how to compute percentages, and we'll be practicing a lot of that. We're going to find dimensions like length and width of a scaled copy of a rectangle and converting fractions, decimals, and percents. And if you looked at the back side of today's handout, you'd see there's going to be plenty of practice with that. For our first question, flags are many sizes. It says one standard size for the United States flag is 19 feet by 10 feet. On a flag of this size, the Union, that's the name for the blue rectangle in the top left corner filled with stars, that's 7 and 5/8 feet by 5 and 3/8 feet. There are many places that display flags of different sizes. Let's find the size of a classroom flag using the scale factor of 1/5. Find the length and width of this flag. Now, part of the reason was last week when we did our Khan Academies, we did review some of that information on scaled copies and scale factors. So remember, a scale factor is changing all parts, all dimensions of a figure. And in this case, we're talking about a rectangle. So we have a rectangular flag. It says it's 19 feet by 10 feet. So we'll label that. One little mark represents feet. Two little marks like that would be inches. So 19 feet by 10 feet. And it tells us we're going to use a scale factor of 1/5. So just like, and it's been a little while, just like we would do, we would multiply all parts of that flag by our scale factor, 1/5. Hopefully you're remembering that if our scale factor is less than 1, it's going to decrease the size of whatever we're multiplying. And that's obviously going to be true. We're talking about a large American flag, and now we're talking about a smaller version of that in a classroom. So we're going to be making a smaller representation of it. So how do we find the length and width of the classroom flag? Well, we just need to multiply. We'll take both dimensions of the 10 by 19 flag, multiply it by 1/5 to get our new dimensions. So let's start with the shorter side. So 10 feet times 1/5 is going to be our first calculation. So we'll find 1/5 of that size, and that is 2 feet. So on the actual flag, that's 10 feet. It's going to be 2 feet on the classroom sized flag. Then we do the same with the length. We'll multiply that, by 1/5. And to do 19 times 1/5, our scale factor, we would get 3.8 feet. Now we could make that into a fraction as well. I don't know that it really matters, but we could, that's 3 and 8 tenths, just because of the place value this number's in, this decimal place. So I could write 8 tenths, but I would want to simplify that fraction. And to simplify that fraction, 8 and 10 can both be divided by 2. I would get 3 and 4/5. 3 and 4/5 feet. 3.8 is fine also. All right, our next question says the side lengths of the state flag of Colorado are in the ratio 2:3. If a flag is 12 feet long, what is its height? All right, now usually we describe length as being the longer dimension and the horizontal dimension. So if this flag is 12 feet long and we're trying to find the height, Well, that's supposed to be a question mark. If we're trying to find the height here, then we're going to have to use the ratio that it gives us. So it says the side lengths of the state flag of Colorado are in the ratio 2 to 3. Now, stay with me on what that means. So that means if our ratio is 2 to 3, the shorter dimension to the longer dimension is 3. That's what that ratio is telling us. So we could have all kinds of different versions of that. We could get larger, and we could say, so now we just need equivalent ratios. So if we double the height of the flag, then we double the length, the length of the flag. So this is going to become 4. This is going to become 6, and these ratios would be equivalent. We could keep going larger, or we could go smaller even. And we could do half. We could say if this is 1, then this is 1.5. All right, but we basically need to figure out what that ratio is for a flag that has a length of 12 feet. Now that would be a great example to use a table for. We could set up a proportion also, because what we're saying is, let me write the proportion here for you. We're going to write our ratio, 2 to 3 is equivalent to something over 12. Or again, if we had a table, we would look at it as, let's see here, height and length. And we'd have 2 to 3. And we could put all of these ratios in here that are equivalent if we wanted to. And then we're missing that one ratio. Any way we look at it is going to be fine, but here we're reviewing kind of scale factor, but also proportional relationships. So this ideas that we've learned at the beginning of the year are carrying through so much of our math that we continue to do. So what I hope you're seeing, and we could look at this a couple of ways. Let's look at the ratio here, or the proportion, because we haven't looked at that in quite a while. But I turned this part of my ratio from 3 into 12 by multiplying by 4. I have to keep this proportional by doing the same here. So we've got 8 as our missing dimension. The height of the flag is 8 feet. All right, at the bottom of your page, we've got a conversion diagram here to kind of help. And we're just trying to demonstrate how to convert between decimals, fractions, and percentages. Now you can see the arrows showing which direction you're traveling, and this can be kind of your cheat sheet for the back tables that we're going to be completing. So please take a look at this, but I would rather just demonstrate what we're talking about here today with a few examples. So I am starting with the full column there on the left of your paper, if you would turn your paper over with me. And we are starting with a number as a decimal. We're going to have to change it to a fraction and a percentage. So let's do that. Now, if we go back to this, we're starting with a decimal. We're going to a fraction, and then we're going to a percentage. Okay? So you can see here in the description, it says use place value in the decimal digits. Let's talk about that. So we're going from decimal to fraction. So if my decimal is 0.3, this place value has a name. It's the tenths place. So a better way to say this decimal instead of just 0.3 is 3/10. Right there, I have a fraction. The way that I said that, 3/10 is 3 over 10. Now, if I have to simplify it, that's always a good practice to get into. But since I know 3 is a prime number, that's not going to be able to be simplified. 3/10 is its simplest form. Now we're going to go from decimal to percentage. And it says here, multiply by 100. So I'm taking this decimal, multiplying it by 100 to get my percentage. Now, 100, let me write this, 100 is 10 times 10. Every time we multiply something by 10, it just increases all the digits by one place value. So if I were to multiply 3/10 by 10, it would become 3. This 3 moves into a larger place value. It moves up a place value. So multiplying by 10 turns this to 3. Multiplying by another 10 turns that 3 into 30. And that would be our percentage. Okay, now one quick interesting thing about percentages. Percentage has the description of what a percentage is right there. Per cent. And cent is a word form of 100. So what we're doing is we're really comparing this number out of 100. So we're saying, well, we're saying this number here is 30 out of 100, whatever we're talking about. Okay, whether it's a survey of people, whether it's the amount of work you have left to do or whatever, we're comparing out of 100 things, there's 30 still there, still remaining. All right, now that is how we're going to be completing this next table, these next 5. And if you look at the back of your sheet, the 5 at the top of each column are all the same. So let me do one more for you just as an example. Let's look at, actually, let's jump down here. Let's do one that has 2 decimal places. Okay, so 0.75. This is also read as 75 hundredths because that's the hundredths place that we're ending in. So I would go ahead, I would write that just as I said it, 75 hundredths. And it's okay to leave it like that, but simplifying is always good practice. These can both be divided by 25. So that would simplify to 3/4. Then if we wanted to turn 75 hundredths into a percentage, it's really already sounding like a percent per 100. 75 hundredths is 75%. Remember, we multiplied that times 100 to get the percentage, so the 75 moved up 2 place values. All right, let's look at another example. Now we're starting with a percentage. So if we go back to our diagram real quick, we're starting at percentage, and of course we're going to become a decimal and a fraction version of that. So you can read those descriptions. Let me explain how I would do that. So I would first move from percentage to, let's see, what's that column? That column is decimal. So I need to go from percentage to decimal. So instead of what we just did, which was multiplying this times 100, I'm going to now divide by 100. I'm going to get 2 place values smaller. 80% is 80 per 100. If I wrote that as a decimal, it'd be 80 hundredths. Now, most of you are realizing I don't need this extra 0 here at the end. It's just a useless digit right here. It's not holding any important place value. So it's really best to write it without it. Okay, and that would be how we'd write 80%. If we needed a fraction, I would just hop from here to fraction. After reading my decimal, this is 8/10. 8/10 is 8/10, and that's because of the tenths place that 8 is sitting in right there. Okay, if I had left the 0, that's okay. I would just want to write 80 100ths because this is 80 hundredths. And I'm just going to have to simplify it a little bit further if I do that. So really you're adding a little extra work by doing that. But to simplify 8 tenths, both of those are even numbers. They can be divided by 2 and simplified to 4 fifths. All right, let's take a look at one more way here, which is down at the bottom of that column now. I'll leave 1/2 for you guys because that one's hopefully going to be a little bit easier for you. Let's say 1/5 here. Okay, now this one's a little tricky. I need to turn this into a decimal. Okay, now really, all fractions are division problems. So if you're stuck, divide. 1 divided by 5 will tell you what the decimal version of that is. But I'm going to do it the old-fashioned way. So I know that I need, in order to give a decimal, a number that's compared to 10 or 100 or 1,000, something that is a place value that I can fill in. So 1/5 can be turned into an equivalent fraction out of 10. If I double my denominator, I'm going to double my numerator. So 1/5 is equivalent to 2 tenths. That very easily can be written as 2 tenths. So decimal version. And then to get my percentage, I'm going to compare this now out of 100. So one thing I could do here is just stick a 0 on the end if I wanted to. That brings me to the hundredths place. This is 20 hundredths. 20% is what I would be writing for my percentage. Or again, think of multiplying by 10 and multiplying by 10 again. Increase this 2 place values to 20%. All right, this practice on the back of your sheet is going to be very important for you to do. The more comfortable you get going between fractions, decimals, and percents, the better this unit is going to go for you. So please take the time on this, ask questions, ask for help, jump on Zoom if you have any questions or want me to just explain, re-explain or explain a little bit differently what I'm talking about here. So please complete that practice, look for the answer key on the end of the Edpuzzle, and I hope to see you on Zoom with questions. Have a good day.